This is the work table in my shop. Originally, today was going to be a reenactment of a peep massacre. But if you look down here, you'll see I don't have very much left. I've got some peeps in a milk chocolate egg and a little secondary milk chocolate egg. Everything else has been eaten. So instead of the delightfully bloody peep massacre, which I was looking forward to, I'm going to be spending a little bit of time showing you what you can do if you've built your own CNC mill and some of the adjustments you have to make to get it working. Okay, so at this point I've got an indicator mounted in the mill. Now an indicator is used for measuring distance. So what you see here is we have this dial filled with lots of numbers, and when I go ahead and push this little plunger, you can see that the dial moves in response to the plunger being moved. So this guy actually has 1 inch worth of range, and we're going to use this to detect backlash on the machine. Okay, so at this point you probably hear a little bit of hissing. That's actually noise coming off of these motors here. A little bit of the noise is also coming out of the control box down here. But what you'll see is I've gone ahead and set the dial indicator to read 0 at this particular place. Here's the actual control panel, and you'll see the x-axis, that's the one we were looking at down there. Up here is set to 0 also. So theoretically, if we were to move the table around in all sorts of different places, we would end up with it back at 0. So I've switched screens on the CNC controller here to this screen called MDI, which I think it's called Manual Dialogue Input or something like that. But this will allow me to write a very simple program to move the carriage on the mill from one precise spot to another. Then I can measure the difference of what we actually see. And just for reference, the way you program a CNC machine is through this language of what's called G-codes, which are a throwback to the 70s from some of the very original CNC machines. We're just going to use the G0 rapid positioning this time around, and what you'll see here, we're just going to use G00 to do a rapid move to 1 inch and back and see how the machine compensates. So I've noticed a problem in my setup here. When I went to move some stuff on the table, I noticed that if I touch the indicator, we're going to -1 thousandths, but if I go back the other way, looks like the indicator setup itself has some backlash in it. So I'm going to spend a minute trying to figure out where that's coming from before I proceed with actually testing the machine, since problems with the indicator setup could amplify any error that's inherent in the machine itself. So you can see here, to deal with that backlash problem I was having with the indicator, that I completely rethought the setup. I've got the indicator mounted to the moving table now, indicating on the fixed surface of the head on the z-axis. So what you can see here now is we're at 0. When I push things, I end up just a little teeny bit shy of 0, but honestly, this first calibration I'm doing on this machine is just to get it in the ballpark. I've got some very low precision parts I'm going to be working on. I don't really care about having it that accurate. Okay, so here we are back at the controller again. And so first I'm just going to move the table over 1/10 of an inch. So we'll use the G00, which is the rapid positioning, and then we'll say the x-axis 0.01. So you can see we moved pretty much right to 10 thousandths of an inch. So this lead screw is accurate going in one direction. Now we'll return x back to the 0 position. Aha! You can see we're actually about 1/1000th short of coming back to 0 position. So that meant when the table moved out and then back, it actually lost 1/1000th of an inch of travel. Alright, so we're just going to pop over to the backlash compensation in our program here and add 0.001, since that's what we measured. Now it's important to note, in an ideal world you'd actually fix the machine to compensate for backlash, but once again, I'm not working at that high of precision, so it's easier just to compensate in software, which does have some drawbacks, but I'm not going to explain those. So now I'll demo the same thing again with the back compensation turned on. And we'll just spin it all the way around too to see where that brings us to. So now it's pretty much just coming back to 0 all the time. And we are done for today.